Hello students, hello everyone, welcome to my channel and this is Kiran Potina. Hope everyone are super fine and awesome. Hello students, welcome to my channel, this is Kiran Potina. Students, now you are going to learn very basic and important points of trigonometry, whether you are studying in state or CBSE for 10th class. This video is going to be very helpful for you. So without let us start the concept. So actually the word trigonometry is derived from Greek words. So by using three Greek words, so those are tri, gon and then metron. Tri means we know three and gon is nothing but this is sides, and here metron is nothing but measure. As you know already, trigonometry is nothing but measuring three sides, that too particularly of a right angle triangle. So measuring three sides of a right angle triangle is considered as trigonometry in starting days. But nowadays there is a vast applications of trigonometry. See, as you started learning trigonometry in 8th standard, maybe 8th, 9th, it will be there in 10th. Even if you go to class 11 and then class 12, even in degree level or in engineering level or in PhD level, see wherever you go, so trigonometry will follows you. So for that purpose, why? Because the vast applications is even in astronomy, applied sciences, everywhere, wherever you go, the trigonometry will follows you. So that's why you should have very strong and good foundation regarding the chapter trigonometry should be there. And particularly in this video, see, I want to discuss some important 5 concepts regarding the trigonometry. Those are, the first one is trigonometric ratios. So what are trigonometric ratios? I will explain. The second point is trigonometric identities, and then the third point is how to find the values of trigonometric ratios. Detailedly I will explain. And then the fourth important point is concept of even angles and odd angles. Maybe you did not heard about this even angles and odd angles, but I will explain clearly so that you can convert and you can transform any angle. It may be sine 180 degrees minus a, like that. Any angle you can transform easily. And the last and main important concept for this video is the intro to heights and distance. So this is the going to very important topic and you will understand very easily. So let us start the topic with this trigonometric ratios. Come on guys. Yes. First of all, what do you mean by trigonometric ratios? How many are there? Okay. So we will call the trigonometric ratios as sine theta, particularly cos theta, and then tan theta. Here, what do you mean by theta? Theta is nothing but an angle. Angle is the union of two rays having one common endpoint. Angle is the union of two rays having one common endpoint. So this is called an angle. So that will represent with theta. So with that we will take this sine theta, cos theta, and then tan theta. So I will explain briefly. Like these three are having three siblings. They are having, like sibling of sine theta is nothing but cosecant theta, cos theta is nothing but secant theta, tan theta is nothing but cot theta. Why I am telling like these are siblings means, see, as you know, in our houses, siblings means always fightings will be there, always opposite, but they will be together, but always fightings will be there, like they will say opposite. Okay, if I want to see the sports channel, he want to see the movie, like that, it will be there. So why I am telling like that is, for example, say I will give you, for example, if I consider a right angle triangle, so with some theta here and it is a perpendicular line. See, always we have to consider the right angle triangle. So to identify the trigonometric ratios, where the side opposite to that angle we will consider as opposite side, or else perpendicular, we can also call perpendicular, and the side which is to this perpendicular and the angle, this one will consider as adjacent side, or some will call it as base. And this line, the longest line in this triangle, will consider as hypotenuse. Right. Now how we have to describe about that sine, cos, tan, cosecant, secant, cot regarding regarding this triangle is, I will give you a formula, that is OAOHHA. OAOHHA. So here OAOHHA represents is trigonometric ratios only. So I will mention this as sine, cos, tan. Nothing but sine is nothing but O by H. Okay. Sine theta is nothing but O by H. Here O represents opposite, H represents hypotenuse. Clear? Next, cos theta represents A by H. Here A by H. A represents adjacent and H represents hypotenuse. And then next, so here tan theta represents O by A, nothing but opposite by adjacent. Now why I call these are cosecant, secant and cot theta are siblings means, so these are just opposite to this. Why? How opposite these are? Like if it is cosecant theta, this will be like hypotenuse by opposite. So that is called here H by O. So this is cosecant and this is secant, H by A. Secant is nothing but H by A, which is hypotenuse divided by adjacent, and then here this will called as cot. Cot theta is equal to adjacent by opposite. Okay, like this, quite opposite to this. So that's why I call these as like siblings. So understood? See, if you consider this right angle triangle where the theta opposite to that theta will consider as opposite side, and this is called adjacent or base, and this is called hypotenuse. So based on this you remember OAOHHA. First three represent sine, cos, tan. If you take sine, cos, tan, we have to follow this order, numerator by denominator. If you consider cosecant, secant and cot, you have to follow this order, denominator by this numerator, like H by O, like this. Okay, hope you understand this trigonometric ratios. Now what do you mean by trigonometric identities? So particularly we have three formulas which we will call as trigonometric identities, which are very useful for those are like sine square theta plus cos square theta is equal to 1. So this is the most important formula. Another one is secant square theta minus tan square theta is equal to 1. This only someone will write like secant square theta equal to 1 plus tan square theta. Next, the third one is cosecant square theta minus cot square theta is equal to 1. Nothing but cosecant square we can also write 1 plus cot square theta. Why these are very important means, so for example I will take one example out of that, that is I will take sine square theta plus cos square theta is equal to 1. So from this one formula we can derive more than 4 formulas minimum. So how we can write is sine square theta is also called as 1 minus cos square theta we can write, right? And again from this cos square theta we can write as 1 minus sine square theta we can write, right? From this only. Now from this one we can write sine theta is equal to square root of 1 minus cos square theta. So again from this one we can write as cos theta is equal to square root of 1 minus sine square theta. Okay, like this from one formula minimum we can find the 4 formulas. Similarly from this we can find 4, again from this we can also find 4. So these are the these 3 formulas we will consider as trigonometric identities, and these 6 ratios we will consider as trigonometric ratios. And why this particularly called as ratios means, as we are having ratio of those sides, so that's why these are called trigonometric ratios. Now coming to next topic, that is values of trigonometric ratios. Students, now I will tell you how to remember all this. So to remember, see, if you have 6 trigonometric ratios and 5 different angles like 0 degrees, 30 degrees, 45 degrees, 60 degrees and 90 degrees. 6 trigonometric ratios, 5 angles, nothing but 6 into 5, 30 spaces will be there. So instead of remembering all 30, if you remember at least 5 points or nothing but 5 values, so based on those 5 values you can all remember all those 30 values. See how I will tell. See, first you have to remember the first sine values. So nothing but sine 0 degrees is 0, next is 1 by 2, next one is 1 by root 2, and this is root 3 by 2, and this is 1. So these are the values which will help you to find the remaining all 25 values, remaining 30 values. So those are, see here. First, when you have written sine, if you write from the reverse opposite side like this, that will become cos. See what are those? It will become first here 1 and then root 3 by 2 here, and this is 1 by root 2 and 1 by 2 here, and this is 0. Understood? So if you remember first values like 0, 1 by 2, 1 by root 2, root 3 by 2 and 1. If you write opposite like in reverse order, then we will get cos. Next, tan. What do you mean by tan theta? Tan theta is nothing but sin theta by cos theta. You remember this point, so you can also find this this row also. So as sin by cos, 0 by 1, 0, 1 by 2 divided by root 3 by 2, 2 and 2 cancel, we will get 1 by root 3. Next, 1 by root 2 by 1 by root 2, both will be cancelled, we will get 1. Root 3 by 2 by 1 by 2, 2 and 2 cancel, we will get root 3. 1 by 0, 1 by 0 is nothing but undefined. Why? Because anything by 0, remember guys, anything by 0 is always infinity, will write, or else we can write as undefined. Okay, remember this. Next, cot. See, starting only I told you like siblings. So sin reciprocal is nothing but cosecant, and cos reciprocal is nothing but secant, and vice versa. Tan reciprocal is cot. Okay, reciprocal we will do now. See, cot is nothing but reciprocal of tan. So 1 by 0 is undefined here. So 1 by root 3, nothing but if you do reciprocal we will get root 3. 1 by 1 is 1 only. Root 3 reciprocal madre will get 1 by root 3. And again now 1 by infinity. 1 by infinity is nothing but 0. So as anything by 0 is infinity, 1 by infinity is called as 0. This also remember. Why 1 by infinity is 0 means infinity is generally nothing but something by 0. If we reciprocal this, 1 into 0 by 1 we will get nothing but 0. 1 by infinity is 0, anything by 0 is infinity. Okay. Next, secant. Secant is nothing but reciprocal of cos. So cos is here. Reciprocal of 1 is 1. Reciprocal of root 3 by 2 is 2 by root 3. Reciprocal of 1 by root 2 is root 2. Reciprocal of 1 by 2 is 2. Reciprocal of 1 by 0 is undefined. Next, the last and final, the cosecant. Cosecant is reciprocal of sine. So 0 reciprocal is 1 by 0 is undefined, and then 1 by 2 is 2. 1 by root 2 is root 2. Root 3 by 2 is nothing but 2 by root 3, and reciprocal of 1 is nothing but always 1. So see guys, like this we have to find the trigonometric ratio values, nothing but those angle values in terms of these trigonometric ratios. And in particularly in your class 10, when you are discussing applications of trigonometry, nothing but heights and distances. So what are the values which are very important and helpful for you is, see guys, I will mark these. So these are the values which are going to help you a lot in this heights and distances, nothing but applications of trigonometry. So at least you remember this. Sin 30 means 1 by 2, sin 45 1 by root 2, sin 60 root 3 by 2. Similarly, tan is 1 by root 3, 1 root 3. So tan values are also playing very important role in this coming exercises. Okay. So make a note of all this and remember. So next I am moving to concept of even angles and odd angles. May someone of you know this and someone may not. So but I will explain clearly guys. So listen this. Okay. First of all, so I will consider a two-dimensional plane. Two-dimensional plane is nothing but we will have two axes. One is x-axis and the other one is y-axis. This is positive and this is negative x-axis. Positive y-axis and this is negative y-axis. So actually, for example, if we consider this as the origin, so here the x-axis angle will be always 0 degrees, right? So angle we will consider is 0 degrees here. Next, here the angle is 90 degrees. Why? Because perpendicular. And here the angle is 180 degrees. And here the angle is 270 degrees. And again, if it completes one complete revolution, it will become 360 degrees, right? You know about this. See, now the concept is, so when two straight lines divides this plane into 4 equal parts, those we will consider as quadrants, right? Quadrants. So this we will consider as Q1, Q2, Q3 and this is Q4. So what are these Q1, Q2, Q3, Q4 is nothing but quadrants. And then in first quadrant, so the angle will be lies between 0 to 90. Second quadrant, wherever you take a line, so the angle lies between 90 to 180. This is 180 to 270 and this is 270 to 360. And in first quadrant, if you take any trigonometric ratio, like for example like this, so here angle formed is theta. If you consider the any trigonometric function theta, nothing but, see, I will show you. See, these all values are lies between only 0 to 90. If you observe, all the values are only positive. It may be 2 root 2, 1 by root 3, 1 by 2, 0, infinity, but these all always positive, right? So that means in 0 to 90 degrees, you take any trigonometric ratio, that will be always positive. So that's why we have a shortcut to remember that, that is all silver teacups. All silver teacups. See, what are these teacups? Are nothing but these are not teacups. So this is the remembrance only for. So to easy remembers, we will use this all silver teacups. Here all represents all are positive. That means if you take any angle, any trigonometric function in this area, this is positive only. So here silver represents only sine and its reciprocal cosecant theta are positive. So remaining all are negative. Here T represents only tan and cot are positive, remaining are negative. Here C represents here cos and then its reciprocal secant are positive. So remaining except these two, here in this quadrant except these two, in this quadrant except these two, remaining all are negative. So why I told you these all is that will be used here in even angles and odd angles. Now let us move to this concept. See guys. So even angles andre odd angles andre. So here even angles means angles on x-axis. Angles on x-axis will consider as even angles, and then odd angles means angles on y-axis. Angles on y-axis. So angles on y-axis andre what it will come is like 90 degrees to 70 degrees. Again after one complete revolution, again 360 will happen. 360 plus again 90 will get 450, nothing but 90 degrees or 450 degrees. So then also we will consider those as odd angles only. Now here angles on x-axis will consider as even angles, nothing but 0 degrees and then 180 degrees it will become, or 360 degrees for one complete revolution. Say after one revolution again it will come 180 degrees, 450 after 90, or this is 540 degrees. These are also will consider as even angles. Simply angles on x-axis is or even angles, angles on y-axis are called odd angles. Now what is the use of these even angles and odd angles in our trigonometry is, see for example, see guys, for example if it is like sine 90 minus a, 90 minus a, so a is some angle, so 90 minus, so whenever we have 90 minus we have to take it as cos a. So if we are having cos 90 minus a, we have to take it as sin a, and when we are having tan 90 minus a, we have to take cot a. So why we have to take like this, I will explain here. So when the angle is odd angle, functions will change. Okay, functions will change. How the functions will change is like, so when we are having sine here, it will changes to cos, and again if we are having cos, it will changes to sine. If we are having like secant, it will changes to cosecant. If it is cosecant, it will changes to secant. If we are having tan, it will changes to cot. So vice versa, cot means it will changes to tan. So which type of cases is like this? So sine we are having 90 degrees, we are having nothing but, so 90 degrees is an so odd angle, right? Why? Because it is lies on y-axis. Angles on y-axis are odd angles. So when we are having like that, so functions will change when we are having odd angles. Sine to cos, cos to sine, tan to cot. Similarly, cot to tan, sine to cos, secant to cosecant, cosecant to secant. So instead of 90, see, if we are having like sine 180 minus a, 180 minus a, so we will write it as only like sine a. Okay, How also I will tell. Why? Because 180 is nothing but angle on x-axis, right? So this is 180 degrees angle on x-axis. So if the angle on x-axis nothing but even angles, if you are having even angles, function does not change. Function doesn't change. So doesn't change is nothing but remains the same. Okay, remains same. That means sine is there means sine only, cos is there means cos. Like for example, cos 360 minus a is nothing but cos a. So okay, so why? Because 360 degrees is nothing but angle on x-axis only. When we are having angles on x-axis, function does not change. Sine means sine, cos means cos. Okay, these are nothing but transformations. Next, when we are having odd angles, it may be 90 degrees or 270 degrees or else 450 degrees, like that. When we are having like that, so it will changes to like this. So hope you understand. Now see, after that, see, after changing into like functions like sine to cos, cos to sine, tan to cot, similarly when the function does not change, what about the signs? Whether we have, when come to signs, it depends on this all silver teacups. Okay, so see guys this one carefully. So when I have written 90 minus a, 90 minus a means this is 90 degrees, minus is nothing but it belongs to first quadrant. First quadrant, if you take sine, cos, tan, any function, so it will be always positive. Okay, it may be sine, cos, tan, secant, cosecant, cot, any function. 90 minus is represents first quadrant, so always anything is positive. Next, here sine 180 minus a, 180 minus means this is 180 degrees, minus represents this is q2, nothing but second quadrant, right? So when it represents second quadrant, which are positive? Only sine theta positive and cosecant theta positive. So that's why when we are having sine and 180 minus, it will become positive sine a, right? So instead of sine 180 minus a, if I write tan 180 minus a, okay, tan 180 minus a, as we are having even angle means what happens? Function does not change, right? So function does not change, and afterwards as tan is in this quadrant, okay, 180 minus, tan is in this, here tan is not there, that means tan is negative here. So when tan is negative, so tan 180 minus a, I will write it as minus tan a. Why? Because even means function does not change, as usual same function, but it will be quite opposite, nothing but negative. So and again another example I will give, like secant 270 minus a, secant 270 minus, so this is at 270 degrees, right? 270 minus means it represents third quadrant. In third quadrant only tan and cot are positive, secant is negative, so we have to write minus cosecant a. Why minus cosecant a? Means as we are having odd angle means what happens? Function changes, secant changes to cosecant. At the same time we have to write negative sign. Why? Because secant is positive in this third quadrant. Okay, like that we have to write. And this here particularly cos of 360 minus a, cos 360 means even angle, function does not change. Okay, function does not change as it is. And then cos 360 minus, this is 360 minus means fourth quadrant, nothing but q4. In q4 cups, nothing but cos and secant are positive, so that's why cos is positive. Okay, like that we have to take, it may be 90 or 360 or 180 or 270, any trigonometric function you can write, it may be positive or negative, or function will change based on this concept of odd angles and even angles. Students, still if you have any doubts regarding this concept of even angles and odd angles, so please WhatsApp to my number. So this is my number 9148686 not only regarding this concept of even angles and odd angles, if you have any doubt regarding your class 10 mathematics, so you can message me to this WhatsApp number and I will do the video, or else I will explain after, at least by solving the question, and I will send. Okay, so next, coming to the last and final, the very important topic for you, that is introduction to heights and distances. See guys, in this heights and distances you need to remember these 6 points what I will write now. So those 6 points are, first of all, observer and object. Observer and object. See guys, see for example, So like this is an eye. Okay, so this is an eye. So eye is watching some like a bird. Okay, watching a bird. So then this one will consider as observer, or person who is watching that is called observer. Whom they is watching, that will called as object. That may be bird, or that may be building. Okay, that may be pen or pencil, anything. So what, okay, who are watching, that is observer. To whom they are watching, that will consider as object. Okay, and the distance between, okay guys, the distance between that observer and the bird, the distance between observer and bird, we will consider as line of sight, is called as line of sight. Okay, the distance between observer and the bird is called as line of sight. I will give you another example to understand this, and the remaining terms you need to remember is, those are horizontal line, okay, horizontal line, and this is angle of elevation, and then angle of depression. Angle of depression. So these all the words you need to remember while solving the heights and distance problems. Why? Because they will be in terms of this line of sight, horizontal line, angle of elevation, some degrees, angle of depression, like that. Now what about this? See for example, I will consider a person. Okay, so who is standing on the ground, nothing but an earth. So in front of a building is there. Okay, some 3 story, okay, G plus 2, this is ground floor, first, second and third floor, okay, like that, for example. So like for example, a bird is there here, a bird. Okay, so a person is watching that bird. Okay, person is watching that bird. So the distance between that, this person eye and this object, so this we will consider as line of sight. This is called line of sight. Now afterwards, okay, this is about the line of sight. Already I told here, the distance between that eye and that bird or nothing but object is called line of sight. So this is over, and observer also over, object is also over. Now what do you mean by horizontal line? Horizontal line is nothing but when you take a parallel line from the ground. So this is the ground, right? So this is the ground. If you take the parallel line, so from to the eye, okay, parallel line to the eye. Now the distance between that eye and this building is called the horizontal line. So this is called horizontal line. Okay, next. Now what do you mean by angle of elevation? Angle of elevation and depression. The difference between that angle of elevation and depression means, elevation means angle formed when we see the object upwards. Angle of depression means when we see downwards. Okay, remember these two. Depression means down. When we are depressed, we will sad. When we feel sad, we will look down, right? So similarly, angle of depression means when we see downwards. Angle of elevation means when we elevate, nothing but when we see upwards. So here the angle found between that horizontal line and then line of sight, okay, that theta only here we will consider as angle of elevation, nothing but AOE, right? So this is called angle of elevation. Next, for example, that same person, okay, and that same person went to the top of the building. Okay, so let it be like this. My diagrams are awful, but the content is okay. Okay, see this, for example, this is the building, and like for example, the bird came here. Okay, when he is observing from that height, okay, the bird, now again the distance between that eye and the bird will consider as line of sight, right? Line of sight. Now here what do you mean by horizontal line? So many will mistake here only. Horizontal line means they will take this only. Horizontal line nothing but from the object to this building. No, we should not consider horizontal line like this. So horizontal line means the line which is parallel to the ground, and we have to start like this from the eye. So this is called horizontal line. And the angle between horizontal line and this object, this will be always like 90 degrees will be there. Here also 90, here also 90. So this is line of sight and this is horizontal line. Okay. Now the angle found between horizontal line and the line of sight will consider as theta, and here the theta is considered as angle of depression. Why? Because when he is observing downwards, that angle will consider as angle of depression. When we see upwards, that will consider as angle of elevation, right? So hope you understand the concept of what you mean by line of sight, horizontal distance, angle of elevation, and then depression. Now the another important points you need to remember, so before starting the problems of heights and distances, is some points to remember. See here, so these points are based on this line of sight, horizontal line, angle of elevation, and then angle of depression only, but note down these points. This will be very helpful for you. Okay, see in solving the question, see first point, a plane level parallel to x surface is called horizontal plane level, and a line drawn parallel to horizontal plane is called horizontal line. Okay, so that is nothing but a straight line which is drawn parallel to the ground is considered as horizontal line. So this is also ground. Okay, here also this is the ground, and the line straight parallel to that will consider as horizontal line. So that is first point. A line drawn parallel to horizontal plane is called horizontal line. Next point is, if the observer moves towards the perpendicular line, nothing but building, then angle of elevation increase. Yes, very important point. See for example, a person is there on the ground. See when he is watching this building. So for example, when he is watching this top. Okay. So this is considered as a line of sight. Okay. This is line of sight and this is horizontal line, right? And this theta will consider as angle of elevation. Consider as theta 1 I will consider. Theta is considered as angle of elevation, right? So when he is moving towards the building, for example, he reached here. Okay, he reached here. So the angle of elevation. Now here this will be the line of sight, and the angle is also increases, right? Theta 2 is also considered as angle of elevation only. But when compared to this is very small angle. Let it be like 30 degrees like that. So when we reach up to some distance, it will become 45 degrees and still like that. But when we reach here, it will become 90 degrees, right? So when an observer moves towards the perpendicular line, nothing but the building, the angle of elevation increase, right? So similarly, when he moves away from that, okay, like when he moves away from that, so this will become line of sight, and this will become angle, nothing but theta 3. So this is very small when compared to this and this. Okay, so that is only here. If the observer moves away from the perpendicular line, then the angle of elevation will always decreases. Okay, so this is about the important points, and then introduction of heights and distances. As I said, still if you have any doubts regarding any concept in your 10th class, or if you want to solve any exercise, any particular exercise in any chapter, just you message to this number 91486866345, which is my personal number, and you do only WhatsApp a message you do, so I want this chapter or I want this topic, so I will explain to you. Okay, thank you everyone. See, if you think that this video helps to you, so please subscribe my channel and share to your friends. Thank you. Have a nice day.